Hey everyone, welcome back to the channel. In today's video, we'll see what is NAT Gateways in AWS and we'll understand why do we need NAT Gateways in AWS VPC. So before understanding this, we'll understand this diagram. So if you understand this diagram, we'll fully understand how NAT Gateways work. So let's break down this NAT Gateway diagram step by step so you can clearly understand how private subnets securely access the internet. So first you can see under the VPC layout, inside our VPC we have two subnets, private subnet and the public subnet. So the public subnet is connected to the internet through an internet gateway. Here you can see IGW, and the private subnet has no direct connection to the internet, and that's by design to keep its internal server secure. So question come, why NAT gateway exists? So inside the private subnet cannot reach to the internet directly. So if we have some instance here, suppose we have EC2 instance, so it cannot be direct reachable to the internet. So but they still need the internet. They require internet for OS update, download, package, reaching APIs. So however, we do not want to expose them. So we place a NAT gateways inside the public subnet. Here we place a NAT gateways. So what this can do? So this allow outbound traffic but block inbound traffic. So outbound means outgoing traffic and inbound means incoming traffic. Next, we'll understand the traffic flow. So now let's follow the number. So here you can see private instance sends outbound traffic. Here private instance. So inside the private subnet, the instance send an outbound request. For example, checking for software update. Understand this point. Inside the private subnet, we have the instance send an outbound request. For example, updating the software update. Since the private subnet route table point to the NAT gateways, the traffic goes from private subnet to the NAT gateways. So this is line mark 2. Here you can see. Now next step, NAT gateway forward traffic to the internet. So once the traffic reaches to the NAT gateways, the NAT gateway performs source NAT. It replaces the private IP address with its own public IP. So now traffic is passed to the internet gateway and finally reach out to the internet. So next response come back securely. So when the internet responds, the response come back to the NAT gateway's public IP. NAT translates back to the private IP to the instance. Finally, the traffic flow back to the private server. So the important point here is the internet can never initiate a connection to the private subnet. Here, internet cannot initiate a connection to a private subnet. Only respond to a already initiated request that are allowed. So this keeps the private subnet fully secure. So final summary from the diagram. We have private subnet, NAT gateways, internet gateways, and internet. So outbound request only, no inbound request allowed. NAT lives in public subnet because it needs public IP, and private servers stay hidden but still access to the internet. So this is the safest way to allow internal server to communicate externally without exposing to the public internet. Now we'll see the important points. So we already know what is NAT gateway. Let's go once again go through it. So it's allow outbound and internet access from private subnets, as we explained earlier. Allow only outbound internet access from the private subnet. Next, block unsolicited inbound internet traffic. Next point, keep private servers secure and hidden from the internet. So it keeps private servers secure and hidden from the internet. Uh, Next, used when server need updates, as I told earlier, patch, API calls. So in that condition, we use NAT gateways. Next, why not use internet gateway for private server? So attaching internet gateway makes this subnet public. Remember this point. Attaching an internet gateway makes the subnet public, and public subnet exposes server to the external links. So NAT gateway allow outbound access without inbound exposure. It's keep inbound like it's keep private, but best for private EC2 instance needing safe internet access. Next, we'll see how NAT gateways works. So private instance send an outbound request. So for private instance for downloading OS update or downloading package, it will send outbound request. So traffic flow, private subnet to the NAT gateways and internet gateways. Response returns NAT gateways private instance. Internet cannot directly connect to the private subnet, private instance. So internet cannot directly connect to a private instance. Next component need to use NAT gateways. So internet gateway attached to a VPC. As we all know, internet gateway always attached to a VPC. Public subnet will default route to the internet gateway. So with default, it always route to the internet gateways, public subnet. Next, NAT gateways deployed in public subnet. Always remember, we deploy NAT gateways in public subnet. Private subnet route table default route to the NAT gateways. Next, NAT gateway traffic flow. Private instance send request routed to the NAT gateways. Second point. Third, NAT gateway to the internet gateways. Response return to NAT gateways. So this is the traffic flow of a NAT gateway. Private instance send request routed to a NAT gateways, and NAT gateway is connected to a internet gateways, and response return to the NAT gateways, and NAT gateway forward to a private instance. So NAT gateway configuration nodes require internet gateway for external connectivity. Deployed in public subnet only. CIBA public IP slash elastic IP, and private route table must direct traffic to a NAT gateways. AWS handles scaling, maintenance, and ability. So all this. Now we'll see high ability for NAT gateways. So NAT gateways are ability zone specifics. Deploy one NAT in each ability zone for redundancy. If one ability zone fails, NAT in other ability zone continues working. Avoid downtime for outbound traffic. So now we'll see summary what we have learned so far. Outbound internet access for private subnet. No inbound traffic allowed for the internet. Require internet gateway plus public subnet plus elastic IP. One net per ability zones recommended for high ability. Full managed AWS service with 10 GW throughputs. So that's all from this video. I will see the conclusion. NAT gateway ensures secure outbound internet access, and it keeps private server protected from threats critical for production workload needing updates or APIs. Reliable, scalable, and secure solution for modern cloud architecture. So that concludes this video. I hope you enjoyed this video, and please subscribe. I will keep updating. In the next video, we'll see more networking concept. So that's all from this video.